So having examined nearest neighbors as a very simple way of how we can use them to predict categorical and as well as real valued outputs, for example, to do regression, we will now talk about a state-of-the-art method that is used for classification. And the method goes under the name of support vector machines. And this method will really scale to large-scale data, and it will allow us to do what is called classification. And the example application we'll be talking about is the application of email spam filtering. So imagine we are a big email provider, we are receiving lots and lots of email, and for every email that comes through our servers, we would like to decide whether to flag it as spam or whether we kind of put it in our users' inboxes. So the way we can think about this problem is the following. We can think that we are having an email, and we will represent each email as a long vector, where it will be a simple binary vector, where every entry or every component of this vector will correspond to a different word, and simply a value 1 will indicate that a given word appears in the document, and value 0 will indicate that a word does not appear in a document. So for example, imagine that I have a set of 3 emails, where the email number 1 has words Viagra and the in them, while for example, the second email has the words learning and the in them, and the third document has Nigeria in it and other words as well, right? And for each of these documents, I also know their label, right? I know whether they are spam. So for example, first and third documents are spam, while the second document is not spam, okay? So I can think about this as an instance space where x's are instances of my data. Let's think that I have n data points. In our case, I will have what we will call them binary features, right? Because the entries of x are binary values. And imagine that every x has d dimensions, which means that we have d features, d different characteristics that describe our data point. In our case, there is 1 dimension or 1 feature per word, which means that we will have around 100,000 or 1 million features. So every email now is a 1 million or 100,000 dimensional data point. Now, having described the instances x, now the question is what is the class space, y, and our class is very simple. It's a binary variable, so it's a classification problem where we want to decide whether a given email is spam or whether it's ham, whether basically it's not spam. And the way we will be using our models to do this classification is that we will use what is known as linear models. And we will think about a very simple linear model, right? So we will think of our function f of x to have a very simple form. We will say, we will predict that the email is spam if some weighted combination of words that appears in the document is greater than some threshold. Otherwise, we will predict -1. Right? So all we are basically doing is we are taking these binary values, whether the first word appeared in the document, whether second word appeared in the document, whether the third word appeared in the document, and doing a weighted summation, where the weight of every word will basically tell us whether that word in some sense votes for the email to be part of the spam domain or whether for that email to be part of the non-spam domain. So simply, right, if we have x1 to be a word Viagra, then we would expect it to have a high positive weight so that the whole sum will be greater than 1. And if we have a word learning or data mining, maybe the x2 is a word learning, then its corresponding weight w, we would expect it to be negative or hope for it to be negative because this is an indication that our email is not spam. Okay? So the way we think about this is that our input is a set of vectors x and y, where x's are real valued or binary valued. In our case, we will now take these big binary vectors and we will normalize them so that their Euclidean length equals 1. And our goal is to find vector w, right, with the same length, same number of components as x has, such that w now kind of separates out spam from non-spam. So the way we can think about our data now in this case is that we can think of our data instances as being embedded in this d-dimensional space where this is the first dimension and this is the second dimension and so on. And then one part of these data points is not spam, so let's think of this as minuses, and the other part of the data is spam. So we think of this as spam, we think of down here as ham. So our goal now will be to find, in some sense, a line that separates pluses from minuses, that kind of separates spam from ham. And to find this line, we will be using tools from linear algebra. So our idea will be that basically what we want to do is the following. Imagine that we have this W, this weight vector, these weights that we are using when doing the inner product with our features x. Then basically what we are saying is that we want to find a line, this blue line, where W times x equals our parameter theta, right? So as I have it up here. And now if this product is positive, then we will be making one prediction, and if the point is on the other side of the line, then we will be making the other prediction. And kind of the whole goal, or the hard part here will be, how do we find these weights W, right? How do we find W such that it represents this line that separates spam from non-spam? So to be a bit more precise, this is an example of a linear classifier, where basically the idea is that every feature, every word in our case, has a weight associated with it. And then the idea is that our prediction is based on the weighted sum of the weights of the features and the corresponding feature values. So simply writing this out, we can think of this as a dot product, inner product, between the weight vector W and a vector representing features of our data point. And then once we have done this dot product, this weighted summation of features and their weights, then we simply say that the f of x gives a positive prediction if the W times x is positive, and it gives a negative prediction, or it gives a different class if the f times x is negative. So the way we can think about this is the following. We can think that in our space, every word is a separate dimension. So now a document or an email is simply a point in this d-dimensional space. And our goal is to find a line such that all the spam emails fall on one side of the line and all the non-spam emails fall on the other side of the line. The question is, of course, how do we find this vector W, or equivalently, how do we find the line?